Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I am your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, End of Life for ML, a C-level playbook for retiring, replacing, and decommissioning models. Why this episode? Because companies pour time and capital into models, then let them linger until they become liabilities. Stale predictions, hidden costs, compliance gaps. That drift eats ROI and multiplies risk. In the next 22 minutes, I'll lay out decision criteria, governance patterns, a phased decommission checklist, and executive KPIs you can use to turn model sprawl into a managed portfolio. Turning data into business impact means not just launching models, but knowing when to stop them. That's the difference between models and value.
To frame practical advice, I'll lean on a composite perspective, a senior chief data officer and head of ML Ops who's run portfolios at scale across finance, retail, and operations. I'll summarize their journey and the scale we're talking about so you can match these ideas to your context.
Think of a leader responsible for hundreds of models, tens of millions of daily predictions, and cross-functional SLAs with product, legal, and operations. They've inherited models from acquisitions, pilots that never graduated, and experiments that quietly became business decisions. Their challenges? Balancing ongoing innovation with the steady burden of maintenance, technical debt, and regulatory obligations.
Their career path is familiar. Built early models in a data science team, scaled to production in ML Ops, then moved into enterprise governance, the shift from building to curating. This view matters because retirement decisions aren't purely technical. They're product, legal, financial, and operational choices wrapped in code. When leaders treat retirement as tactical housekeeping, you get surprises. When leaders treat it as capability, you free capacity and reduce exposure. Let's get practical. How do you decide whether a model should be retrained, replaced, or retired? I group decision criteria into 4 buckets: performance, relevance, cost, and compliance. Start with performance decay. If predictive accuracy or calibration slips below business thresholds and the cost to restore that performance, data collection, engineering time, and testing exceeds the incremental value, retirement should be on the table. Next, business relevance. Has the process the model supports changed? If the label no longer correlates with the business outcome, retraining won't help. Then, cost to serve. Models that are expensive at inference or require complex feature pipelines can be cheaper to replace with rule-based logic. Finally, compliance or legal risk. Models using outdated data or undocumented lineage are regulatory liabilities. Any one of these buckets can trigger retirement, but the strongest cases combine more than one.
To operationalize this, translate those buckets into executive KPIs, cost to serve per prediction, delta in expected business value from baseline, incidence of SLA violations tied to model error, and compliance exposure score. Track them on a quarterly cadence and require a retirement review when thresholds are breached.
A common trade-off is retrain versus replace. Retrain when the business signal is intact and the feature pipeline remains stable. Replace when the model's operational overhead or inference cost is the dominant problem, or when a simpler approach captures most of the business value. Retire when neither retrain nor replace is cost-effective, or when the model creates governance or legal risk. Practical tip: always compute a break-even window, time and money to restore expected value versus projected value lost while resources are applied elsewhere. Let me give 3 short real-world examples. In finance, a credit model trained on pre-pandemic behavior can become biased as borrower patterns shift. If remediation requires new data sources that the organization can't reliably capture, retirement plus manual underwriting may be safer. In retail, a demand forecasting model linked tightly to a deprecated SKU taxonomy can be replaced by a simpler top-level forecast until the taxonomy migration is complete. In operations, predictive maintenance models that depend on expensive sensor feeds may be retired when sensor availability drops and rule-based thresholds suffice for safety compliance.
Pitfalls to avoid: retiring without stakeholder alignment, failing to preserve data and artifacts for audits, and not providing a graceful degradation path. We've seen models abruptly disabled, causing downstream teams to scramble and customers to receive inconsistent experiences. The governance step that requires cross-functional sign-off, product, ops, legal, finance, prevents those crises. Include rollback plans and a monitoring window after decommissioning to detect unintended consequences.
Now, governance and leadership. Make retirement an explicit board-level capability. That doesn't mean a monthly meeting to micromanage every model. It means the clear portfolio policy, life cycle stages, retirement triggers, responsible owners, and budget for decommissioning. Treat decommissioning as a line item in engineering budgets. Allocate 5 to 10% of model lifecycle spend to end-of-life activities, data extraction, archive, monitoring windows, and legal audits.
Leadership KPIs should include percentage of models with documented owners and retirement criteria, average time from retirement decision to full decommission, and lifecycle cost aggregated per model. For risk, measure model exposure, the count of models with stale lineage, untested fallback strategies, or unmaintained feature stores. These KPIs give executives the leverage to fund lifecycle work and reduce operational surprises.
Communication matters. Tell product teams why retirement is strategic. It frees capacity for higher impact work and reduces fragile dependencies. Tell customers or regulators where relevant. A planned sunsetting with clear timelines and fallback behavior preserves trust. And be explicit with teams about what success looks like for retirement. Archived models with retained lineage, agreed SLAs for fallback, and a validated rollback plan. Technically, I recommend a 5-step decommission checklist. 1. Flag. Create a canonical retirement ticket with reason and owner. 2. Isolate. Route live traffic to fallback or safe mode while preserving the model endpoint. 3. Monitor. Run a 2-week shadow window comparing old and fallback behavior. 4. Degrade gracefully. Throttle the model or reduce scope before shutdown to catch edge cases. 5. Decommission and archive. Freeze code, snapshot data and model artifacts, record lineage, and conduct a post-decommission audit. Each step must have acceptance criteria and a rollback trigger.
Looking forward, bake retirement into portfolio management. Use a catalog that includes retirement metadata and automated flags, drift detectors, cost anomalies, and SLA breaches that produce retirement tickets automatically. Contractually, include model life cycles in vendor and partnership agreements so external models have clear sunset clauses. Over the next 12 to 24 months, leaders should prioritize cataloging and automated health checks. These aren't flashy, but they materially reduce surprise exposure.
A practical horizon plan. In month 1, build the inventory and retirement thresholds. Months 2 through 4, automate the most common health checks and establish the monitoring window for flagged models. Months 5 through 12, run several controlled retirements to exercise your playbook and prove you can decommission without downstream impact. Use those exercises to refine KPIs and cost estimates. Before we close, 2 actionable takeaways you can share with your leadership team this week. 1. Deploy a simple retirement checklist. Flag, isolate, monitor, degrade gracefully, decommission, and require that every model has a retirement owner and criteria. 2. Add 3 executive KPIs to your dashboard: cost to serve per model, time to decommission, and % of models with documented retirement criteria. Use those to prioritize budget for lifecycle work. Final reflection. Retirement is not an admission of failure. It's discipline. It protects customers, preserves capital, and clears runway for new high-impact initiatives. Leaders who institutionalize retirement win sustainable AI portfolios.
That's the difference between models and value.
If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.